This question is from Geotechnical Engineering from the topic three-phase diagram. In this question it is asked that in order to find the relative density of sand, a mold of volume 1000 ml was used. When the sand was dynamically compacted in the mold, its mass was 2.10 kg, whereas when the sand was poured in loosely, its mass was 1.635 kg. If the in situ density of the soil was, this is 1.5 megagram per meter cube, and sand is saturated with G is equal to 2.70, the relative density is asked in terms of percentage. We know that the formula for relative density is equal to E max minus E divided by E max minus E minimum into 100. Now E max will be calculated by this mass, that is when it is dynamically compacted here, and E minimum would be calculated when the sand was poured in loosely, that is void minimum void ratio would be in this one, that is when it is dynamically compacted, and maximum void ratio E would be in when the sand is in loosely compacted state. E, that is in situ density of the soil, would be calculated from this data. We know that rho max saturated state is equal to G plus E minimum divided by 1 plus E minimum into rho W. Now rho max saturated is equal to 2.1 into 10 raised power 3 divided by 1000, that is this mass divided by volume, that is this 1000, 2.1 divided by 1000. From here we get converting it into gram per mg per liter, 2.1 gram per milliliter. Similarly, rho minimum saturated would be 1.635 into 10 raised power 3 divided by 1000. This can be calculated from this mass divided by this volume. So again the value comes out to be 1.635 gram per milliliter. So putting the value here, we get rho max is 2.1, G is 2.70, E minimum we have to calculate E minimum into 1. From here we get E minimum to be 0.545. Similarly, rho minimum would be G plus E max divided 1 plus E max into rho W. From here we get E max to be 1.677. Now how to calculate this E, that is in situ E? In situ density of the soil is 1.50 mg per meter cube, which is equal to 1.5 gram per milliliter. This is rho D. Again we know that E is equal to G rho W divided by rho D minus 1. From here we get 2.70 divided by 1.5 minus 1.80. So putting the value of E minimum, that is here 0.545, E maximum 1.677, and E, that is in situ density, 0.80. In this equation, relative density equation, we get RD in terms of percentage. The E maximum is 1.677 minus 0.80 divided by 1.677 minus 0.545. So the value comes out to be into 100 77.47% answer.